So first question, children, worksheet number 11, first question. A player kicks up a ball at an angle theta. Player kicks up a ball at an angle theta. It was given. Okay, something like this. So the ball was being kicked. At what angle? Some theta angle it was being given. With the horizon. The horizontal range is maximum. To get the maximum range, what must be the angle of projection? We know the formula for R is equals to U square sine 2 theta by G. To have the maximum range, what is the value of maximum range? It should be U square by G. When do we get U square by G? Whenever this sine 2 theta equals to 1, you will get it as maximum range. When is sine 2 theta is 1? Whenever 2 theta is equals to 90 degrees. Isn't it? So because sine 90 is 1. So sine 2 theta is 1 means 2 theta must be 90 degrees. What is theta? 45 degrees. So you'll get the maximum range whenever the body is thrown with an angle of 45 degrees. So your answer must be third option. So horizontal range is maximum whenever theta is equals to 45 degrees. So this is what I have explained here. So for theta equals to 45 degrees, you'll get the maximum range. Is that clear, children? Well, moving to the next question. If R is the range for an angle of projection of 15 degrees, what is the angle given? 15 degrees. With the horizontal, then the other angle of projection for which the range is R is. So just now I have explained. So the two angles of projection for the same range. So if it is one is 15 degrees, the other must be, one is theta means the other must be 90 minus theta, you'll get the same range. If one is 15 degrees, the other is 90 minus 15 must be 75 degrees to get the same range. Okay, so what is given? The R is range for the angle of projection 15 degrees with the horizontal, then the other angle of projection for which we get the same range is, that is theta is 15, 90 minus theta is 90 minus 15, it must be 75 degrees. So option number 1, 75 degrees. Moving to the next question. If the velocity of projection of a projectile is treble means made 3 times at a given place, then its maximum range will be. First of all, let us write the formula for range. What is the formula for range? U square sine 2 theta by G. Of course, this is the formula for range. Okay, well, then what you are saying is maximum range will be, maximum range means R max, simple. R max will be U square by G. Range is U square sine 2 theta by G. Maximum range is U square by G. Clearly, this G is always constant. Okay, the value of G always remains constant on the surface of the earth. Okay, 9.8 it is generally taken. So from this we can conclude that R is proportional to this maximum range. R max is proportional to U square. If R is proportional to U square, then we have R1, let me replace now, U1 and R2 proportional to U2, something like this. Okay, then R1 by R2 equals to U1 square by U2 square. R1 square by R2. Comparing two different equations based on this formula. R1 means U1 square I'll take, R2 means U2 square I'll take. So what is this equals to? What is given, children? If R1, I name it as R, you are asked to find out R2. U1, if it is U, U2 is tripled, 3 times of U. This is the given data. Based on that, what we'll do is R1 by R2 equals to U1 square by U2 square. R1, name it as R. R2, I need to find out. U1, let me name it as U square. And U2, what they made? U2 means the velocity of projection of the initial, if it is U, it is 3 times, tripled, 3U whole square. Don't get confused with the bracket. U2 means 3U, whole square means 3U whole square. Hence you have R by R2 equals to U square by 3 square is 9U square. Solving this u square and u square gets cancelled. Then you are left with 9r, cross multiply. 9r is equals to r2. Let me rewrite it. R by r2 equals to 1 by 9. Cross multiply, bring this r2 here, then what will become? R2 is equals to, bring this 9 the other side, 9r. So what happened? The range, the new range will become 9 times of the previous range. So how many times? It becomes 9 times. Is that clear, children? So simple formula for r is u square sine 2 theta by g. Okay, maximum range is u square by g. Since g is constant, what we compare is r1 by r2 equals to u1 by u2 whole square. u1 is given as u means u2 is given as 3u whole square. Simplify, you get the new range as 9 times of the previous range. Moving to the next question, the time of flight of a projectile is maximum when the angle of projection is. Children, what is the formula for time of flight? It is nothing but 2u sine theta by g. In order to get the maximum value, this sine theta must be 1. Then, maximum value of time of flight will be 2u by g. Okay, so sine theta, to get the time of flight maximum, for maximum time of flight, the value of sine theta must be equals to how much, children? 1. Okay, this value must be 1. Then only you will get the maximum value. When is sine theta maximum? Whenever theta is equals to 90 degrees, we will get sine theta as, that is sine 90 as 1. Hence, your answer would be 4th option, 90 degrees. Okay, next question. The range of a projectile for a given initial velocity is maximum when the angle of projection is 45 degrees. We know this. The range will be minimum for the angle of projection of. Let us see. Range formula. What is the formula for range, children? U square sine 2 theta by g is the formula for range. For maximum range, in order to get the maximum range, this sine 2 theta must be 1. For maximum range, we have sine 2 theta equals to 1, isn't it? So if sine 2 theta is 1, 2 theta equals to 90 degrees and 2 theta equals to 90 degrees and theta equals to 45 degrees. Of course, we knew this. But what they are asking is minimum value. To get the minimum value, again we know that u square sine r is equals to u square sine 2 theta by g. To have the minimum value, this sine 2 theta, for r minimum, sine 2 theta must be minimum. We know that for the trigonometric function of sine theta, its value range from 0, 1 by 2, 1 by root 2, root 3 by 2 and 1, 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Minimum is 0 and maximum is 1. That's it. So, sine 2 theta must be 0. Sine 2 theta must be 0 means theta equals to 0 degrees or theta equals to 0 by 2 0, but no 0 is there. Not only this, children, either 2 theta equals to 0 or 2 theta can also be 180 degrees. Because sine 180 is 0. To get 0, either you can take this 2 theta as 0 or either you can take 2 theta as 180. If 2 theta is 180, then theta must be equals to 90 degrees. So, either for theta equals to 0 degrees or theta equals to 90 degrees, you will get the minimum value of r. Hence, as 0 is not there in options, your answer must be second option, that is 90 degrees. Two ways. Next question. If air resistance is ignored, so if you suppose that there is no air resistance, no opposing force due to air, okay, then the horizontal motion of the oblique projection is this parabolic path. Okay, this is called as an oblique projection, takes place. So the whole journey will takes place. Air resistance is not there. Okay, then how the body may move without air resistance? The body will move with uniform velocity. That's it. The speed doesn't regain or speed does not decrease. The body completely move with uniform velocity whenever the air resistance is ignored. Hence option number 4. Okay. So forget about acceleration. Acceleration always changes. Okay. Place to place. Okay. So what is the value? Uniform velocity. Air resistance is ignored. Uniform body moves with uniform velocity. Next. An oblique projectile has the smallest speed on its trajectory when does the body have the minimum speed? Smallest speed means, see, this is the projectile body. Here some u velocity, it is been released, gradually decreases and then it reaches maximum point, its velocity becomes 0, and again when it reaches back to ground, its velocity again increases. Here velocity decreases, velocity increases, and at the maximum height its velocity is 0. So the smallest speed on its trajectory when it is at the maximum point or the highest point is at the highest point. At the point of projection it has maximum velocity, hits the ground again, reaches the same, the horizontal distance traveled by 1/8, no, not at all. Maximum height or at the highest point, its speed or its velocity is 0. Next, in the case of an oblique projectile, the velocity is perpendicular to acceleration. Okay, so what is this? In the case of an oblique projectile, the velocity is perpendicular to acceleration. Everywhere we know that acceleration always acts downwards. Yes or no? But what about the velocity? Here, if you observe the velocities, here the velocity is something like this. Everywhere the velocity direction changes. The velocity can be given by the tangent drawn at that given position. Okay, this is parallel. Here also it is parallel and some small angles in. But here if you observe at the highest point, this velocity vector is perpendicular to the acceleration. Throughout its journey, because here it is parallel, children. Both cases parallel, but here it is perpendicular. What they're asking is, in the case of an oblique projectile, the velocity is perpendicular to acceleration. How many times? Only one particular time, that is at the highest point. So once only. Parallel means twice. Parallel or anti-parallel. Okay. This is anti-parallel and here it is parallel. Perpendicular means only once. Next question. If the height attained by a projectile is the greatest maximum height, then which of the following is maximum? Yes. What is maximum? Horizontal range, angle of projection, force of gravity, or time of flight. Yes, height attained by the projectile is greatest, then which of the following is maximum? There is no relation for horizontal range and height attained. Okay, u square by g. Angle of projection nowhere. Force of gravity. Answer is must be time of flight. We can't say anything from this. But for time of flight, I also went with this equation. T is equals to root over 2h by g. I derived the same. So the height attained by the projectile is maximum. H is maximum. 2 is constant. G is constant. So clearly T is proportional to h. So h is maximum means time of flight must also be maximum. So answer must be time of flight. Okay. Well, next question. If the initial velocity of a projectile is doubled, keeping the angle of projection same, the maximum height reached by it will be. Velocity, what they happen is doubled. Okay. The maximum height. What is the relation between maximum height and velocity, children? H is equals to u square sine square theta by 2j. Hope you remember the formula for h. H is equals to u square sine square theta by 2j. So here very clearly velocity they are changing. Angle of projection same means sine theta is constant. 2 is always constant. G is always constant. So clearly h is proportional to u square. Okay. Velocity is doubled. So clearly h1 by h2 is equals to u1 by u2. u1 square by u2 square or u1 by u2 whole square. So h1 by h2 is equals to u1 by u2 whole square. Clear? What they have given is, let us suppose this h1 as h, u1 as u, and what they did was u2. Initial velocity of projectile is doubled. So second case velocity, what happened? Initial velocity u means velocity now became 2u, doubled. Substituting in the above equation, we have h by h2 equals to u by 2u whole square. U got cancelled. Then we have h by h2 is equals to 1 by 4, or h2 is equals to 4h. That means that new height has become 4 times of the initial height. The maximum height reached by the body will be 4 times of the previous one. 4 times means quadrupled. 4 times means quadrupled. Okay. Now, the next question. Two bodies are projected at an angle. One is theta and the other is 90 minus theta to the horizontal with the same speed. The ratio of times of flight. Children, we know the formula for time of flight is 2u sine theta by g. Okay. So, one angle it was given as theta. Other angle it was given as 90 minus theta. This is what they have given. Two bodies are projected, one angle is theta, the other with 90 minus theta. The same speed. The ratio of the time of flight is, and they have given with the same speed. Clearly 2 is constant, g is constant. Same speed they have mentioned, u is also constant. So clearly t is proportional to sine theta. This implies t1 by t2 is equals to sine theta 1 by sine theta 2. Isn't it? Substituting in the above equation, we have t1 by t2, which you are asked to find out, equals to sine theta 1 is nothing but sine theta. Theta 1 is theta. Sine theta 2 is taken as 90 minus theta. Solving this, we have theta 1 by theta 2 equals to sine theta. Sine 90 minus theta. Okay. Sine of 90 minus theta will become cos theta. 90 minus theta is cos theta. 270 minus theta, 90 minus theta is cos theta. Therefore, T1 is to T2 is found to be sine theta is to cos theta. Hence, option number 3. Okay, well, moving to the next question. In the above question, that means in the same question, the above question, ratio of horizontal ranges. Now you are asked to find out the ranges. Time of flight we have considered here. Now you are asked to find out the ranges. Children, what is the formula for ranges? Range is equals to, what is the formula? So u square sine 2 theta by g. Above formula means theta 1 is taken as theta, theta 2 is taken as 90 minus theta. Hence r1 by r2 you are asked to find out. Okay. Clearly we know that same speed and same value of g. U square is same and g is also same. Hence r1 by r2 will become, what is that value? Will children? Sine 2 theta by sine 2 90 minus theta. So so clearly r is proportional to sine 2 theta. r1 by r2 is equals to sine 2 theta 1 by sine 2 theta 2. So replacing the values, r1 by r2 is equals to sine 2 theta 1 I considered as theta and theta 2 I considered as 90 minus theta. This is nothing but sine 2 theta by sine 2 into sine 90 minus theta can be written as 180 minus theta. 180 minus 2 theta. Therefore, r1 by r2 is found to be sine 2 theta upon, earlier I have already discussed what is the value of sine 180 minus theta is again sine 2 theta. So cancel. Therefore, the value of R1 is to R2 is found to be 1:1. So option number 1. Okay, so with this we have concluded the exercise number, worksheet number 11 from the same concept, and in the next concept class we will be discussing the worksheet number 11A. Okay, so keep practicing children. Meet you in the next class. Thank you.